keep in mind that for right now we aren't introducing any calculus-based topics for multivariable functions. We'll get into that with the remaining modules, but for right now we're just looking at some basic concepts. How do we work with these functions with multiple independent variables? So in match problem 1 and 2, they're both very similar. It just comes down to substituting in some given values for x and y into the equation, and then coming up with that final result. So in match problem 1, we want to find a cost function, or the value of the cost function, evaluated at 20, 10. So just like we would for a function with one independent variable, wherever an x occurs, we'll plug in that value for x. And now since we also have a variable y, anytime a y occurs, we'll plug in our variable for y. So this is going to be 700 plus 70 times 20 plus 100 times 10. And then from there, it's just a calculator operation or a little bit of arithmetic to find that that cost would be $3,100. Similarly, in match problem 2, we still just want to evaluate this given function, but now we're given values for x, y, and z to substitute in. So in this case, rather than 2 independent variables, we have 3. We could have 4, 5, 6. That number could keep increasing. Typically, though, we'll just deal with functions with 2 independent variables. But the process remains the same. We're going to evaluate this at x equals -2, y equals +2, and this new variable z equals 3. So this will be 2 times -2 squared minus 3 times -2 times 2 plus 3 times this value for z, which is 3, plus 1, and then again from there just calculator operations to come up with that function value should be 30. So the ideas here are exactly the same, even though we have multiple independent variables in each case. We're just substituting those values in for x and y, and then just evaluating the expression.